So this lesson is going to be about balanced and unbalanced forces, and the learning target is to be able to identify when forces are balanced and unbalanced based on an object's motion. And so the first question we want to answer is, how do we know that forces even act on objects? How do we know what forces do to these objects? And so when we look at, let's say we had um, a guy, let's call him John, and we had another guy, somewhat meaner guy, comes up right behind him and gives him a push. And we know what's going to happen to this first guy, John. He's going to fall right over. And so he's going to start moving this way. He might fall down, hit his head, crack his head open, end up in the hospital. He maybe dies. The red guy goes to jail. It could be terrible. But we know that the force is acting on an object because when we have a push, we have an acceleration, we have motion. And so we have a change in the motion of an object. And so um, this force was unbalanced, and so we didn't have anything acting on the other side of John. There wasn't somebody standing here trying to hold him up. There wasn't a wall for him to lean up against. There wasn't anything for him to hold himself up against. And so because there was this force here, which was unbalanced, we had acceleration. And so the first way that we know that forces act on an object is because unbalanced forces acting on an object cause acceleration. If I kick a football, it's going to move. If I kick a soccer ball, it's going to move. If I throw a baseball across the room, it's going to move. And so if I apply a force that's not balanced out on an object, that object is going to start to accelerate. And so if we were going to test this out, um, we could test this out with really anything. But if I had, let's say I had, I don't know, a baseball, and it was falling down to the ground, I know that it's falling down to the ground because of gravity. And so gravity is a force acting on that baseball, and gravity is not balanced out by anything. And so this ball is going to accelerate towards the ground. Now, if I put a table underneath this ball, right, once it falls down and it hits the table and now it's just resting on there, well, it's not accelerating anymore. Its motion isn't really going to change. And so this force that was previously unbalanced is now balanced out. And so we have not only a force from the gravity pulling the ball down that we still had before, because gravity still acts on that ball, we now have a force from the table acting upward on the ball. And so now these forces are balanced. And so when we have a balanced force, that object isn't going to accelerate. It's not going to move. It's going to sit right where it's at. Because not only is gravity acting on it, but the table is also acting upwards on it. And so we can test this assumption out by acting a force on an object, and we should see it move. But if we have another force acting backwards on that object that balances it out, the object shouldn't be accelerating. It shouldn't have any acceleration because the force is not unbalanced anymore. So we know that if there's an unbalanced force, the object's going to accelerate. And we know that if an object is just sitting on a table and it's not accelerating at all, we know that the forces are balanced out because we not only have the force of gravity, but we have the force of the table pushing up on that object. And so it is not going to accelerate either. It's not going to fall right through the table. But what if an object's moving and there's no acceleration? So we're going to take a look at, let's look at the skyscraper here. Let's say somebody's standing on the top of the skyscraper and they decide to toss a baseball off the edge of the skyscraper. So this ball starts falling. Initially, there's no unbalanced, or there's no force balancing out the force of gravity, and so this ball is going to take off and start falling towards the skyscraper. And you guys have heard of probably the word terminal acceleration or terminal velocity. Once an object gets to a certain speed, it's not going to speed up anymore, and so this ball is still getting pulled down by gravity, right? But it's not speeding up, it's not accelerating anymore because at a certain point the ball's moving fast enough where the force of the air moving past the ball actually balances out the force of gravity pulling down on the ball. And so when these forces are balanced with each other, this object hits terminal velocity, meaning it will not speed up anymore. And the object is still moving. It doesn't just have to be resting for the forces to be balanced out. But when an object is moving with a constant velocity, the forces acting on it are balanced out. And so if there's no unbalanced forces, it's not going to accelerate. And so when this baseball is hitting terminal velocity, it means that since it is not speeding up, the force of gravity is balanced out by the force of air resistance acting up on it. It'll keep moving downward, but it won't speed up. And so the other principle behind, let's move this out of the way. The other principle behind these balanced and unbalanced forces is that when forces are balanced, there's no acceleration. Balanced forces are equal and acting in opposite directions. The force of air resistance is equal to the force of gravity acting downward on that baseball. And since they're equal in opposite directions, they're balanced out and there's no acceleration. The ball keep moving at the same speed the entire time down its path. And so it's when you're looking for the movement of object, you're trying to decide whether or not these forces are balanced. If you see that the object is accelerating, if you see, for example, somebody being pushed over and they are actually accelerating in this direction, you know that there's an unbalanced force acting on them. And if you see a baseball or something falling and it's picking up speed going downward, you know that there's an unbalanced force of gravity acting on it. And so if the object is accelerating, you know that there is an unbalanced force acting on that object. If you see an object at rest, this would be like the baseball sitting on a table. It's not accelerating, it's not falling down, it's just sitting right there on the table. Or if you see the object, like the baseball that's at terminal velocity, moving in a constant velocity where it's not speeding up, it's not accelerating at all, you would know that there is balanced forces acting on that object. Remember, if you see something that has balanced forces acting on it, the forces are equal to each other and they're acting in opposite directions. You can see that the force of air is equal and opposite to the force of gravity in this situation. And so that's how you can tell, based on what you see, whether there's unbalanced forces or balanced forces acting on an object.